if g of x is 2 minus 3x to the power of 2 over 3, which of the following is true? If we look at our options, g is differentiable for all real numbers, g is decreasing for x is greater than 0, g has a maximum at x equals 0. Well, to find out if each of this is true, we need to do a first derivative test. So g prime of x is equal to derivative of 2 is 0 minus 3 times power of 2 over 3 x, 2 over 3 minus 1, that's negative 1 over 3. So that is equal to, that's 2 over cube root of x. And we see that this never becomes 0. Instead, g prime is undefined when x is equal to 0. So, since g is continuous for all x is equal to 0 is our critical point. So draw the line. This is line x, and here is a 0. We're going to find out whether g prime is positive or negative in each of these intervals. Oops, I made a mistake. We have a negative here, right? So if I substitute negative 1 for x, then this is negative, and we have another negative here. So all of this expression, which is equal to g prime, that's positive. So positive here. If I substitute number greater than 0, so I'm going to substitute 1 plus 1, then this is a positive, but we have negative here. So all of this expression, which is g prime, is negative. So the graph of g increase in this interval, decrease in this interval. Well, the graph of g actually looks like that. Remember, when x is 0, g prime is undefined. If we substitute 0 here, that is undefined, which means that the slope doesn't exist. But since the sign of g prime changes from positive to negative, the graph of g has a relative maximum at this point. So if we look at this statement again, g is differentiable for all real numbers. That's not true. Not true, that's false, right? The second one, g is decreasing for x is greater than 0. Yes, if x is greater than 0, g prime is negative. So g is decreasing in this interval. That is true. The third statement, g has a maximum at x equals 0. Yes, because g increases in this interval, then decreases. It has a relative maximum at x equals 0. So this is also true. So we can conclude that the second statement and third statement are true.